Hi, this is Team 23, and our mentor is Ronnie Jones. This is our final submission. So we'll break this project down into 4 sections. The first section will be the intro, which I'll cover. The second section will be the research and our use cases. Then we'll go into our backend development, and then finally our UI as it is deployed on our HTAP system. So our team details, as we just discussed. So the purpose of our app is to help users manage type 2 diabetes through monitoring activities versus going directly to a medication prescription. So to accomplish this, we will monitor certain things in order to give the user feedback at the time they need it. So if we look at our deployment pipeline, throughout these, it was an iterative process for us, and throughout our production, we increased our production readiness as we went on to more and more complex tasks, and we pushed that feedback backwards in a feedback system. Here's our project plan. You can see all of the different activities that we created throughout our project lifecycle. And then the next slide shows how we divvied those up between each team member and each role that we had. So we followed this pretty rigorously. And that led us to our Gantt chart and our near-term plans. And at this point, our Gantt chart is complete.
The intent based on the customer feedback is to lower glucose levels naturally, track glucose trends and manage daily activities, reduce reliance on prescriptions, provide personal coaching on such as diet, exercise, medications, manage conditions with less time with doctor, reduce likelihood and severity of other drugs. So we did some research on diabetes. So random blood sugar test, fasting blood sugar test, or oral glucose tolerance test are some of the diagnosis measures. Some of the early warning signs could be high blood sugar, hyperglycemic syndrome, increased ketones in patient's urine, low blood sugar. So diabetes symptoms includes but are not limited to increased thirst, frequent urination, increased hunger, unintended weight loss, fatigue, blurred vision, slow healing sores, frequent infections. So there are two main factors that causes type 2 diabetes: insulin resistance in cell and insufficient insulin created by pancreas. So both of these factors impacts glucose levels. The risk factors associated with the type 2 diabetes are obesity, genetics, inactivity, sitting idle for a long period of time, prediabetes, age could be another factor, ethnicity and diet are others as well. So if we translate those into our business cases in blue, that is highlighted in blue, tracking the information data over time, provide the information to patient based on the history, inform them about the risk factor, and coaching the user on how to tackle the diabetes as well as track the um, progress, and that allows user to improve the risk score or risk factor, are some of the business case aspects. So once the application is ready, the user should be able to enter glucose levels and track them, track exercise and diet, observe and print trends. The application should use Fire database, have a landing page deployed through a Docker container, retain user data, provide diet and exercise tracking and coaching.
Hello all, this is Anand Batina. Today I'm going to discuss about architecture, backend and fire integration for our application. So this is our architectural diagram where we see several components. So we developed our UI with the latest Angular framework, and that interacts with the file server to get the medication information as well as authenticate a user. And as soon as we get the patient ID from the file server, which we pass it to the Spring Boot app, Spring Boot app exposes several REST endpoints to perform CRUD operations. Our data gets saved in our H2 in-memory database. So the patient can able to log several information from the UI. So as we see here, blood glucose, diet, exercise, and weight, and the other information. So this is our data model where we have major entities like blood glucose, diet history, BMI history, and exercise history. We pretty much we save all the data into these entities, and and we perform some calculations at runtime to show up some data on the UI. So these are several tools we use for our application development. So we Angular for the UI and Spring Boot for our backend, and IntelliJ and H2 is an in-memory database. We use it to store the data, and SQL to write some complex SQL to perform some calculations at runtime to show up the result on the UI. So we use a Docker, Kubernetes, Drone, Rancher for our deployment. So these are several REST endpoints we use in our application. I'm going to test a couple of REST endpoints from the browser. This is a REST endpoint login, which hit the File servers and authenticate patient ID and password. Basically, password is patient date of birth. So this REST endpoint gets the medication information from the File servers, and we have another REST endpoint which gets the summary data from our database to show a nice graph on the UI, and we have several other REST endpoints to get the static data from our database.
Hi, this is Nayan, and I will introduce the front end of the app. The login, username, and password information provided here is authenticated by the backend with the Fire server. Once logged in, this bar can be used to navigate through the different features of the app. Our research indicates that tracking blood glucose levels, physical activity, diet, and obesity are critical for managing diabetes, and this app helps in tracking all of those. This chart is an important feature of the app. It helps visualize all the historical values of the different parameters that are tracked, and it also helps correlate them. One can pick and choose the parameters to view and correlate. For example, this shows the relationship between exercise, diet, and the blood glucose levels. The user can zoom and pan as required. Now let's look at how blood glucose entries are made. Every new reading has to be qualified with the date, the time at which the reading is taken, and whether the reading is taken with fasting or not. Once added, the reading is then stored and visible in the history over here. Typically, the service provider is interested in tracking two types of readings. One is whether it is with fasting or after a meal. The time at which the reading is taken is also important in adjusting the medication timing. This table shows the average of readings on given dates. The user can click on a date to see the breakup. Readings on a given date can be deleted by pressing on this icon. Now let's see how physical activity is tracked. For physical activity, the total calories burnt are recorded. There are some predefined activities like walking, running, cycling, and swimming, for which the units can be entered for example, 5,000 steps of walking and 2 miles of cycling and so on. And the app will calculate the total calories burnt for these activities and save it in history. Now let's look at how diet is tracked. Our research indicates that the total glycemic load of the food consumed is a very good indicator not just about the amount of food but also its effect on the blood glucose levels. For a new entry, the user has to select date, select a food item from the drop down list here, and enter the number of servings that have been consumed. Once saved, the app will calculate the total glycemic load and add it to the history. The user can select a particular date in history to look at the breakup of the food consumed on that day. Our research indicates that apart from tracking weight, it is also useful to track the waist to height ratio, which is a very simple and good indicator of abdominal obesity. The app also arms the user with a lot of useful information on diabetes and how to manage the risks associated with it. These are external links which take the user to external content. The app also allows the user to retrieve the prescription from a Fire server. So that's all about this app. I hope you found it useful.